Hi, and welcome back to my channel, Learning Biology with Dr. Vanessa. In today's video, we are going to take a look at ionic bonds and how they form. If you haven't already, please go ahead and watch my covalent bond video where I talk about the difference between nonpolar and polar covalent bonds, because I go into more detail in that video of valence shells and electrons, and that will give you a better background for this video. If you already understand those things, you can jump right ahead into this video. In some cases, two atoms that come together are so electronegatively different that the more electronegative atom completely strips the electron away from its partner. This is going to result in the formation of ions, and ions are oppositely charged atoms. And we can have two different types of ions. We can have cations, which are positively charged, and then anions, which are negatively charged. Because of these opposite charges, cations and anions will attract each other, and this attraction is called an ionic bond. Ionic bonds usually form crystals such as sodium chloride, and when they are in the presence of water, they dissociate from one another, and then they are anions and cations when they are dissociated. So let's take a look at how we can form an ionic bond and how they work differently than what we had talked about before with covalent bonds. Taking a look here at the periodic table, we can see that chlorine has 17 as its atomic number, so that means it has 17 protons and it has 17 electrons. So we're going to take a look at what chlorine looks like in a minute. And then we can also see sodium, and that sodium has 11 as its atomic number. So it has 11 protons, therefore it has 11 electrons. So let's set these up and now see what they look like with its electron configuration. What you'll also notice too is that sodium is all the way over here on the left-hand side, and chlorine is way over here on the right. And as I mentioned before, as we travel towards the right, electronegativity increases. So we can tell by looking at the periodic table already, before we even look at the electron configuration, that chlorine is much more electronegative than sodium because it sits all the way over here on the right. So I've drawn out what these two atoms are going to look like. So sodium had 11 as its atomic number, 11 protons, which means it also has 11 electrons. So we have 2 in the innermost shell, filling that up. We have 8 in the second shell, giving us 10, and then we have that 11th one in the third shell. Chlorine has 17, so it also has 2 in the innermost shell, and then 8 filling that second shell, but then it has 7 in the outermost shell. So if you couldn't tell by the periodic table that chlorine was much more electronegative than sodium, you can definitely tell it here. Chlorine has 7 in its outermost shell, in that valence shell, whereas sodium only has 1. So chlorine really wants that 1 electron because it only needs 1 to fill its valence shell, and then it's nice and happy. Whereas sodium needs a whole 7 to fill its outermost shell. So sodium is more like, take my electron away, I don't want it. So what happens in this case is that when they become closely associated like this, sodium very willingly gives up its electron and gives it over to chlorine. And so chlorine will have that extra electron, and if chlorine has that extra electron, it is going to have a negative charge or be an anion because it has 1 more electron, giving it a negative charge. We can also think of it as it has 17 protons, which are positive, but now it's going to have 18 electrons because it took that 1 from sodium. That's 1 more negative charge, making it negative. And then sodium because it lost the electron, sodium is going to be positive because it lost that electron. So it will have 11 protons like its number shows us, but now it only has 10 electrons, one less negative charge, making it positive. So now when sodium and chloride come into contact with each other, them being anions and cations, when they come into contact with each other, they can form ionic bonds. And in these ionic bonds, they normally form things like crystals. So when we see sodium chloride or table salt, you should all be familiar with what table salt looks like. It's in a salt shaker, right? And it's a hard substance. So that sodium chloride is put together in this ionic bond. So this would be an ionic bond. But then if you take that salt and you put it in water and you mix it together, it dissociates. How do you know it dissociates? Because it is no longer a solid material. It completely homogenizes into the water and creates a mixture. And in that mixture, when we add water, we put it into water, we are going to get sodium and chloride, those cations and anions that are going to be now dissociated within the water itself. So this is how an ionic bond forms. It also, like I mentioned before, forms because of electronegativity differences. Now, what's the difference between a polar covalent bond and an ionic bond? So in a polar covalent bond, they are still staying together and they are unequally sharing electrons. In an ionic bond, that more electronegative atom has completely stolen that electron. So they can be separate entities. They will also come together, but now they will come together because of their charges. Thank you so much for watching my video. I hope this helped you understand better about ionic bonds and what they are. If you have any questions or comments, please make sure to put them in the comment box below. And if you like this video, please make sure to subscribe to my channel, like it, and share it with your friends to support me as I continue to make these easy to understand videos.